an angle theta can have any measure in radians between negative infinity and infinity. And since the cosine and sine of any angle depend only on the position of the terminal ray of the angle, each angle theta is coterminal with the angle 2 pi plus theta, or theta minus 2 pi, or theta plus any integer multiple of 2 pi. And so therefore, cosine of 2 pi plus theta for any angle theta is cosine of theta, and sine of 2 pi plus theta for any angle theta is sine of theta. Now, these functions, so cosine of theta is a function of theta and sine of theta is a function of theta. And we'd like to get a picture of the graph of cosine and sine. The graph of y equals cosine of theta, or y equals cosine of x, where x is measured in radians, and y equals sine of theta, or y equals sine of x, where x is measured in radians. And in order to get this picture of sine and cosine, it's enough to get it on any interval of length from 0 to 2 pi, since the function just repeats itself over an interval of length 2 pi. So it's enough to draw the graph on an interval of length 2 pi, and we're going to draw it on the interval from 0 to 2 pi. And then we just add carbon copies side by side to get a picture of the full graph. Now we're going to draw these graphs with Wolfram demonstration. So if you click on these links, it will bring you to a web page, and this is the Wolfram demonstration project. And to use these demonstrations, you have to download some CDF software, which is very easy to download, and you can use it on any computer. And so here, this illustrates the graph of sine of x for x between 0 and 2 pi. And this measure here gives you the measure of x, the angle. And we see here it's 0, it's very, very close to 0. So when x is 0, sine of x is 0. And then as x increases, the sine is the y coordinate here, which gradually increases to 1, and it hits 1 when x is pi over 2. And pi is about 3.14, so pi over 2 is about 1.55. Then as we swing around the unit circle, as x, the measure of the angle, increases, we move on into the second quadrant, and the sine value starts to decrease, and it decreases gradually until it gets to 0 again at the straight angle pi, which we've moved a little bit beyond pi. There it's about 3.14. So it hits 0 again at the straight angle pi, and then as x increases between pi and 3 pi over 2, the y value gets larger in absolute value, the y coordinate on this point, so therefore the sine value gets larger in absolute value and reaches a minimum when x is 3 pi over 2, or when the angle, when I say x here, I mean the angle that this ray makes with the positive x-axis is 3 pi over 2, and when x here hits 3 pi over 2, the sine value hits -1. And then it gradually increases between 3 pi over 2 and 2 pi, it increases back to 0 again. So the end result is that the graph of this sine function for the angle x increasing from 0 to 2 pi is a wave function. And you can play these as videos, and you can see that as the terminal ray of the angle swings around the unit circle from 0 to 2 pi, the second coordinate on the point where that ray cuts the unit circle first increases from 0 to 1, then decreases from 1 to 0, and then decreases from 0 to -1, and then increases again to 0 to give us this wave function for sine of x between 0 and 2 pi. So having done that, we now have a picture of the sine function between 0 and 2 pi. It's this nice wave, and then this wave just repeats itself over every interval from 0 to 2 pi. So if we just juxtapose waves that look like this, then we get a complete picture of the graph of sine of x, where x is the angle that we previously called theta. And so here this is our graph of f of x equals sine of x, and x is of course measured in radians.